Folks, hello. This is a really special evening for me. I mean, outsized in how special it is, just because it's our first time of having folks back in our underground since March of 2019. And so I have missed this. I have missed all of you. And it reconnects me with a part of what I love about the work that I do. I'm Dorothea, I'm one of the owners here, and so welcome to all of you. Thank you for respecting our house rules when you came in. Thank you for wearing your masks and for keeping them on while we're in this shared space here. So just a warm welcome. Also a warm welcome to everyone who has signed in online. This is new for me that I'm speaking both here to the camera and through the camera to people at home, and then to everyone in the room. It's our first sort of experiment, a hybrid event. We'll see how it goes. I'm sure we'll tweak things as we go and make it better. But we just wanted to make sure that people have options according to what feels right in this moment. So just a quick practical thing before I introduce our guests about the Q&A. Because we have folks listening in from home, just when you have a question, I'll come to you with a mic, and let's all use the mic so that folks online can also hear the question. Otherwise, nothing will make a whole lot of sense. And if you are online and you have a question, find the Ask a Question button at the bottom in the center of the screen. And then you can click on that, type your question in anytime it occurs to you. And during the Q&A, we will cull from there as well as call on folks here. So that's our plan. But that's getting a little bit ahead of things. We are, most importantly, of course, all here to honor the publication of this wonderful new book on the life of Vera Rubin by Ashley Yeager. I meant to ask you how to pronounce your name. Is Yeager right? Yes, okay. The life of astronomer Vera Rubin, bright galaxies, dark matter, and beyond. It is Ashley's first book. She is associate news editor at Science News and a prolific science journalist who has written for Quanta, for Science News, of course, Nature, Astronomy, Sky and Telescope, The Scientist, and lots of other publications. And I know I'm blocking the view, I'm blocking the speakers, I'm sorry, but I'm so thrilled that you're here also, Michael. Michael Lemonick is really the best discussant we could have hoped for tonight. Many of you know him probably. He is the opinion editor at Scientific American and has written more than 50 cover stories for Time on science topics. He has written also for National Geographic, The New Yorker, lots of other outlets, and is the author of 7 books, some of which we've celebrated together here in this space. The topics range from the search for another inhabitable planet and other life in the universe to the Big Bang. And his most recent book is The Perpetual Now, a story of amnesia, memory, and love. So I just wanted to flag for all of you that the dedication here, I'm doing without a podium, the dedication is for Darcy, Ella, and all young girls who dream of becoming scientists. And I would say over the last couple decades, women in STEM has become a thing, right? And women in STEM receive recognition and support in new and unprecedented ways. And whether any of that is really leveling the playing field, we can maybe discuss. But Ashley's book returns us to a time when to be a woman in science meant being overlooked, an obstacle at every turn, even someone as brilliant as Vera Rubin. So bright galaxies, dark matter, and beyond goes a long way to righting this wrong. And we are so happy to have Ashley Yeager and Mike Lemonick with us. Welcome. A round of applause. I've missed the applause.
And we've been told to take our masks off while we're speaking, so
yeah.
I'm not breaking the rules. This actually has an interesting echo for me. I was present at the first launch of the space shuttle after it resumed in the wake of the Challenger explosion. So now we're at the first in-person book talk. So it's sort of the same. But I don't think there's anybody worried that we'll explode. One correction to the introduction. This is relatively new. I am the recently retired opinion editor at Scientific American as of 3 weeks ago tomorrow.
Oh,
So,
fun.
yeah, more time to write books. So, I've told this story many times, but not to this audience. I told it just an hour ago. In 2003, when was this? When I came down here? 2006. It's all a blur. I was invited to come give an invited talk on science writing at the University of Tennessee. And so I had this talk, I visited a class, and my hosts were introducing me to faculty members, and I said, because I was already teaching at Princeton at the time, can I get together with some students, because they're sort of the most important people here, which the faculty doesn't always like to hear. And so they arranged a breakfast, and there were 3 or 4 students there. And if you've been in the profession for a long time and you've ever interact with younger people, there are these occasions where you meet students, they're very nice, but every so often one stands out. You say, wait a minute, this one is different. And that's how I felt when we had that breakfast. Ashley's questions were more thoughtful and more sophisticated than the others, and she wasn't just dabbling in journalism. She was really interested in science journalism. And sure enough, she went off to MIT after her undergraduate career, got a graduate degree in science writing, and has gone on, as you've heard, to a really, really successful career as a science journalist, and now she's in the book world. So it's really a pleasure to see you, however many years later this is, I can't do arithmetic, and to see that I was right. Anyway, so it's really exciting to see a biography of Vera Rubin, who was indeed a key figure in modern astronomy, and who went unrecognized, was not given her fair due until relatively late in her career. In fact, she was very modest. I'm going to shut up soon. She was a very modest person. I was at some kind of meeting once, and there were people up there in front, scientists in the front, and she told a story about a young woman who tried to be a scientist, and she was like, she didn't say who this person was. I said, but I knew who the person was. I said, excuse me, who is this woman you're talking about? She had to admit she was talking about herself. She just did not like to toot her own horn. So now I shut up and ask you, I guess the first question is, how did you first encounter Vera Rubin, and how did you get, and what was your impression when that happened?
That's a great question. I first discovered her story working at the National Air and Space Museum in Washington, D.C. I was actually working as an educator in the museum. This was just after I had finished my undergraduate degree. And so we were asked to walk around a specific exhibit. This one was the Explore the Universe exhibit, and try to identify what jumped out at us, what we wanted to interact with visitors about and teach them about. And as I was walking around, I noticed that there weren't very many women represented in the exhibit. And as I kept going, there was a description of Vera Rubin's work. And as I read it, it was a description of a universe that I had never heard of. It was a universe filled with this type of matter that we didn't understand and we didn't know anything about. And I was instantly intrigued. It was something I had never heard about. I had not heard about her work. And so I just started asking a lot of questions. And I kept peppering my supervisor with a lot of questions, and finally he said, well, I've been working on her oral history. Would you like to come with me to interview her? And being 22 and naive and excited, I said, absolutely, let's go do this. And so then we were privileged enough to spend a day with her. We met her husband and asked him a bunch of questions about their life together and her work and was just, she left me with this feeling of being curious, and that was okay, and it was okay to ask questions, and just really being inspired to go learn more about the universe. And so that stuck with me as I progressed in my career, and just something that I just wanted to share with everyone, given the opportunity, and I was privileged enough to be given that opportunity.
Okay, so you worked on this oral history, and was it clear to you at the time how important a figure she was, whether or not she had recognition?
It was not. I just fell in love with the story and the idea of this universe that we didn't understand, and I guess I didn't really understand how important of a figure she was at that point. I did go on to MIT and was asked to do a thesis project, and that's where her story kind of was put into context for me, and I did start to begin to understand just how important of a figure she was, but I still don't think that I fully grasped that for quite some time.
Okay, and I'm not going to give away the whole book. Don't worry. But I'm curious, and I think people here would be curious about, you talk about her getting into science at a time when women were not particularly encouraged. So did she want to be a scientist always? Was this something she always dreamed about?
I think that was the impression that came across. It seemed like very early on she fell in love with the stars. There's a story about her looking out her bedroom window and just being obsessed with how the stars moved. And I would say her family was very supportive of that, in that they really did try to encourage her and take her to amateur astronomy meetings and try to expose her to the idea that she could be an astronomer.
Okay, and whoops. So did you find it kind of easy to do this? And that's a loaded question. We know that she probably didn't, but what are some of the obstacles that you discovered that she faced?
I think there were a lot of obstacles in terms of, I would say, people supporting her. There were obviously people like her husband and others around her that did really support her and helped her foster her career, but then there were other people who told her not to be an astronomer, to take up drawings and do drawings about astronomy.
Drawings about astronomy?
Yes. Or find something completely another profession, in that there were too many astronomers already. So I don't know that it was necessarily easy. I just think the attitude that she kept, her persistence, was what made her successful.
And I learned in your book, which I did not know before, that she did her undergraduate degree at Vassar, was it? Which at that time was a women's college. Did you get a sense from her? Oh, and I should ask you that. You got interested in her in sort of the mid-2000s. Did you interview her at length for this book?
I was privileged enough to go to the telescope with her for a couple of days,
Okay.
and then interviewed her periodically after that.
Okay. So that's how you knew her so well. And this was in the 50s that she went to college, is that right?
Late 40s.
Late 40s, okay, so even further back. Did you get the sense that that going to a women's college was kind of a key step? I mean, I can imagine her going to a colored college and being dismissed because she was a woman. Clearly, they couldn't do that. They wouldn't do that at Vassar. Was that kind of a crucial choice that she made?
I think yes and no. From the research that I did, there seemed to be some I guess, some hesitancy about encouraging a woman in astronomy. They did have an observatory. They did have someone who had the capability to mentor her, but it didn't seem like there was a complete push to have her do this and that she would be super successful and that everything would be okay. I think there were, still restrictions and kind of limitations on expectations for women.
Even at a prestigious women's college, she was not encouraged to do what she was passionate about.
That seemed to be the sense I got in terms of the research that I did, yeah.
So I have met Vera Rubin as well, and interviewed her, and she always came across to me as a kind of a relatively quiet, well, she didn't toot her own horn very much. Very quiet, very sort of soft-spoken, not aggressive, not pushy, and yet she was discouraged. Her mentors, or whatever they were at Vassar, tried to discourage her from pursuing this profession. She did it anyway, so I guess she was more determined than you might think from here.
I think that's true. I think she did have this curiosity about the universe that drove her, regardless of who supported her or did not. And I think that's really what kept her going, even when people might tell her otherwise or to give up or to do something else. She just really wanted to know everything that there was to know about the universe and to ask questions in her own way and to keep pushing forward in that way.
Okay, so she went to graduate school at Cornell, right? And she ended up, as you described very beautifully in the book, working on the question of not only how fast galaxies rotate, but how the rotation of the galaxies, the speed of rotation changes from the center out to the edge. Was this kind of a major, a hot topic in astronomy at the time?
Not completely. I think people were curious about how galaxies rotated. They wondered how fast stars went around the center of the galaxy. And her mentors, Jeffrey and Margaret Burbidge, were looking at this question as well. But there was this assumption that at a certain point, the speeds of the stars, the velocities, would actually drop off because you're getting farther and farther away, and so there wouldn't be matter to kind of pull them around at the same speeds. And people made this assumption, but from what Vera kind of reported, no one really checked that assumption. I mean, there were people who attempted to do this, and there was some radio astronomy work, but this is really, we're talking invisible wavelengths of light that we can see. There didn't seem to be anyone who was trying to go out and find those very, very far stars that sat far away from the center of galaxies. And that's really what she did, was there's this assumption that we have, is it correct or is it not?
Right, the analogy I've often heard is that as you go farther out from the sun, Mercury goes around very fast, Venus goes around slower, and so on out to Neptune and Pluto, which take hundreds of years to go around the sun, and that's according to the Kepler's laws of motion. And I guess there was, I mean, in science, it's often the case. One astronomer I know was a pretty thoughtful guy. Made the observation that if you go out looking, making an observation and you see something unexpected, you perk up and say, wait a minute, what's going on? But if you see what you do expect, you don't double check it. You already assume, okay, this is what I expected, but that it's almost as important to do that, because maybe what you think, what you expect is not true. I guess that is what happened with her.
Yes, so I think she was looking for these stars very far out from the center of the galaxy, and the expectation was that their speeds would be much slower than these stars closer in. And in some of the first galaxies she looked at, particularly Andromeda, which is our nearest neighbor, that is not what she found. The stars' velocities seem to maintain a similar number, and that their speeds were very similar, very, very far out from the center of the galaxy. And so at that point, she started to think, wait a minute, this defies expectations, and there has to be something fundamentally wrong with our understanding of galaxies. There's got to be something else going on.
Okay, so was, when she reported this stuff, so I've had experiences with astronomers who find something odd and nobody pays much attention. They basically say, well, you didn't make very good measurements, you weren't careful enough. We know this is not how it's supposed to be, so we're not going to, we'll pat you on the head and say, go back and do some of the work. How were her observations received?
They were received, I mean, in all honesty, people didn't really believe what she was showing. It was, again, not something that was expected. And so when she first showed this in Andromeda, there was this idea that, oh, well, maybe it's just Andromeda and other galaxies don't do this, so why don't you go look at other galaxies and see if that happens? And that's what she did. And it was galaxy after galaxy after galaxy where she was finding the same behavior. These stars were not slowing down as you got farther and farther from the center of the galaxy. And so there was some theoretical work going on at the same time, suggesting that maybe there had to be more matter in a galaxy than we could see. And so as her observations started to accumulate with all of these galaxies that had stars that were just going insanely fast for what astronomers had expected, that was kind of a point where there was this idea of, okay, we have a problem here. Her data is showing it. Radio astronomers' data are also showing this issue. There's theoretical work. And finally, there was this kind of critical mass in the astronomy community that people had to step back and say, we've got a problem. We need to figure out what's going on in galaxies because it's definitely not what we expected.
I've heard a saying that I don't know if it's a real saying, but no, of course it's a real saying. So Princeton has a very, very good astronomy and astrophysics department, and there are a lot of theorists there. Traditionally, there have been more theorists than observers, and people have said about Princeton in the past, at least, at Princeton, no observation is considered correct until it's confirmed by theory, which is basically the opposite of how it's supposed to work. No theory is validated until it's confirmed by observation, but not here. We do things differently. And you seem to be saying that this was something of the case with her observations. Until the theorists could come up with a theoretical explanation, it just wasn't true.
Yeah, I think part of that is to do with what the explanation was, and that is that the universe is filled with this matter that we don't understand. And obviously, for astronomers studying visible light or any type of light, like that is a big thing to say that the majority of the universe that you have been looking at is not in fact the majority of the universe. And that's kind of really what her observations were showing. And so I think it did take a lot of data and a lot of theory for astronomers to be comfortable with that idea that, we actually really don't have a good understanding of what's happening in the universe.
And in fact, as I understand it, one of the most significant theoretical bits of support that came finally in the 70s for her observations came from Princeton, where Jim Peebles and Jerry Elspecker explained something about the Milky Way, or spiral galaxies like the Milky Way.
Yeah, that's correct. They were looking at kind of how galaxies evolve over time. And if you ran the simulations that they were running with just the matter that astronomers thought were in galaxies, the galaxies would just fall apart. And they didn't develop this beautiful spiral structure with the beautiful arms that we now know exist by all of the images that have been taken of galaxies. And so as they kept running the simulations, there had been some other work that suggested, oh, well, maybe if we add this kind of shell of matter around the galaxies, they'll kind of stick together. And when Peebles and Ostrander ran those simulations, that's exactly what they found. That there kind of had to be this halo or shroud of matter, invisible matter, around these galaxies. And so Vera's work helped to kind of suggest that that actually was a probable cause, because that matter could really be pulling on those outer stars and making them fly around the galaxy much faster than we anticipated.
In the book, you also talk about the fact that this idea about dark matter, which is what we call it now, was actually decades old when Vera made those observations. So tell us a little bit about that.
Yes, so the idea of dark matter existing it goes back a long way, right? Because our technology has gotten better and better, and we've been able to fill in some of these dark spaces in the universe that we might not have been able to see what was there with either the naked eye or early telescopes. But as you get better and better technology, you can see more and more. And so there have been some work in the early 20th century suggesting that maybe there were dark stars or dark nebulae. There were some hints that even in individual galaxies, there might be more matter than we know what it is, but the idea was, oh, maybe we don't have the technology to see it yet. And then in the 1930s, there was a man named Fritz Zwicky, and he started working on looking at clusters of galaxies and how they interact. And those measurements did not match up again with astronomers' expectations. So he suggested, oh, well, maybe there's matter in galaxies that make them interact in ways, in clusters that maybe could explain some of these extraneous observations. And then there was more work in the Milky Way, and then also in Andromeda. But the idea that we don't understand the universe and there's this material that we don't understand was really, really hard for astronomers to grasp, because you have to admit that what you're studying is not the majority of the universe, which I think can be humbling. And so it took some more time. It took better technology. Radio astronomy was a big part of this, to be able to look out farther in galaxies. And then it took someone like Vera, who really went and looked at so many of these galaxies using the tools that she had, which were actually pretty advanced for the time, to be able to find very faint stars far out in galaxies and really kind of collect that data and show that these stars are moving a lot faster than we expected. And so it was kind of this merge of a lot of different pieces of evidence in the late 1960s, 1970s, and then really in the 1980s, where everyone kind of had to take a step back and say, okay, we've got to do something. There has to be some type of matter that we don't understand.
At which point Vera Rubin became internationally famous, a hero, and celebrated by all of her colleagues.
It was a little bit slower than that, I would say. She did give a very quintessential lecture in 1985, basically at the International Astronomy Union. It was a very coveted lecture, and I think that was a critical moment that really said, okay, a big contingent of the astronomy community is convinced that dark matter exists, and now we have to figure out what it is. But it took, I would say, probably another decade really for people to really recognize her name and for some of the other accolades to come along. And I think a lot of that was kind of centered in this push to recognize women in astronomy and women in science and really kind of start to tell those stories so that other women would be inspired to go into science.
Which strikes me as crazy that it took a kind of a social movement in part to give her not just the scientists recognize her, but the social pressure to do that, which is kind of awful. So we still don't know what dark matter is. We're still trying to figure it out, but we're pretty sure it's out there.
I think so, yes. I mean, there are still skeptics because, you know, it was accepted in the 1980s and we still don't know what it is today. So there are people who say, well, we don't know what it is, therefore it must not exist. And there are people who try to explain it away with different mathematical formulas. But I think, and I will say, you know, Vera was open to kind of all of those suggestions until there was firm evidence. So I think it's a search. It's the curiosity. It's this idea that we have it and the theory is there. And we just have to keep looking for it until we either find it or we don't.
And by the way, if the leading theory is correct, I think this is true that it's not just out there, it's in this room right now, right? It's a kind of particle, we think, that doesn't affect ordinary matter, doesn't interact with ordinary matter. So if in fact the dark matter exists, and if it's in the form that most astrophysicists believe it's in, it is in the room with you right now. I don't want to spoil the book. Do you think we should go to questions?
You can ask another question too, and then we'll move to questions. Yeah.
Okay, so not that the committee ever asked you, but do you think she deserved the Nobel Prize?
That's a hard one that I actually try to write around in my book.
That's your rarity.
Yes. Obviously, there are people who think she deserves a Nobel Prize, and there are people who think she does not. I kind of fall on the side of she does.
She hopes so.
Yeah. There is a quote that says, "The person who proves discovers," or the person, is that right? I might have it backwards.
I don't think anybody here knows it, so just.
Okay. Well, I mean, the idea is that once you convince your colleagues that it's real, then, you know, you are the person who has discovered it and identified it. And so I think there's a group of people who says that she did that for the existence of dark matter, therefore she does deserve the Nobel Prize. There are other people who said, oh, she came to the field later, there were people already doing this, then she jumped on the dark matter bandwagon, so she doesn't deserve it. But I think the way she went about her work and the way she did this in visible wavelengths, optical astronomy, which is something that at the time we understood, I think that does lend a lot of credence to the idea that she did do very valuable work in terms of the dark matter field.
And of course, she might have deserved it, but they don't award it posthumously, so it is too late. Just as if Stephen Hawking's prediction that black holes will evaporate over time is finally verified, too bad, because you can't get the Nobel Prize for making that prediction, which is kind of a flaw in the system, I think. Okay, so later in her career, as you said, she did finally start to get the recognition that she deserves. She's got a major new telescope that's going to be named after her, or that has been named after her. Tell us just a little bit about that and what it's going to do.
Sure, so this telescope is pretty incredible. It's going to be looking for evidence of trying to understand what dark matter is. Also going after the question of what is dark energy, this whole other dark component of the universe that we don't understand. And just the capacity to image the night sky is incredible. Really kind of delving into what we can't see, just because the technology is so much better. It's going to be answering a lot of the questions that we haven't quite been able to get a grasp on yet.
And the sort of key thing about this observatory is that it's a very big telescope, although not the biggest. So it's very sensitive to faint objects, but it will take images so quickly that it will essentially make moving pictures of the universe. And there are a lot of things in the universe that change over time. Supernovas erupt, and then they fade. Comets go by, quasars flare and subside. And so every telescope we use now, every big telescope, is really taking static images, snapshots. And once we start taking movies, there's a saying in astronomy, which is probably true in other fields as well, is that every time astronomers get their hands on an instrument that has unprecedented capabilities, when the Hubble telescope went up, that was unprecedented. Nobody had flown a telescope like that above the atmosphere. When we built the first infrared telescopes, the first X-ray telescopes, we discovered things that we never imagined beforehand. And so it's pretty clear that when this observatory goes online a year from now, a couple years from now, Vera Rubin's name will be attached to phenomena that right now we do not even imagine.
And I think that's really representative of her work as well. When she was working at the Department of Terrestrial Magnetism, she was working with Kent Ford, who had an instrument that really could see light that was very, very faint and very, very red. And that provided access to finding those stars very, very far from the center of a galaxy, but also giving you a really good look at things called quasars, kind of these active nuclei galaxies very, very far away. And at that time, it wasn't clear that those galaxies were very, very far away, but she was involved in some of that work just because of the instrument she had available to her in the collaboration. So I think naming this telescope that's going to do these incredible things after her is representative of that.
Well, thank you both. Thank you both so very much. I'm going to have to sit for a minute with the idea that if dark matter exists, it's also here in this room with us. That blows my mind a little bit. So we have time for some questions, and I'll come with the mic. And there was a comment online that it was hard to hear me when I had my mask on. So when you ask your question, feel free to lower your mask and then put it back up so that everyone can hear you well. Okay?
Sitting here listening to this, the name Celia Payne Gaposchkin comes to my mind. And which leads me to ask if you know if Vera Rubin had any sort of a model scientist woman that she highly admired. Celia Payne was a little earlier, but they were overlapping. They overlapped, but Celia Payne was a couple decades earlier than Vera Rubin. But any comments on whether Vera Rubin had a model she looked up to for her science?
That's a great question. So when she was younger, one of the astronomers whose story inspired her was Mariah Mitchell, who was the first astronomer in the U.S. to observe a comet using a telescope. And for which she was awarded a gold medal from the Danish king. And so that was a story that let Vera know that she could become an astronomer, that it was something that women could do. And then I think later in her career, she was able to work with Margaret Burbidge, who was part of the team that really gave us the foundation for understanding how stars create different elements with nuclear fusion, and really showed that you could be a woman in this field and have everything that you wanted to do. You could be an excellent scientist, you could have a family, that was possible. So I know that Margaret Burbidge was someone who did inspire her as well.
I'll come here.
I wonder if you could discuss if you were able to examine the role Vera's husband may have played in advancing her scientific status.
Do you mean in terms of supporting her career? Would you like me to talk about that? Is that the idea? In terms of, I guess, being supportive of her being a scientist, I think he was, I would say, instrumental in helping her advance her career. A lot of the decisions he made about his career really focused on what would be best for her.
What was his career?
He was in statistics, a mathematician. And so again, I think a lot of his decisions helped her with her career in terms of moving to a place where she could continue her education, do her PhD, and then also allowing her to go and do her observing runs out at Kitt Peak in different telescopes and helping with the family. There are a lot of other examples, and basically just supporting her with her work. I know they would spend time talking with each other and talking through some of the things that she was working on. They both really liked to share their work. So there were just a lot of different ways that he really encouraged her.
There's a question back there, but there's also a question online, and I'm going to go first to that and then to your question in the back. I'm going to, for that question, give the mic to my amazing colleague Jacob, who is behind the camera, behind the technology, and has made this hybrid thing possible. So a quick thank you to Jacob. And here's the question from Ramon.
Yes, there's lacking a little context, but it is essentially, we think of the fabric barriers as space and time, space-time. The question is essentially, is one of those two becoming a priority in research today? Is space versus time, I guess.
I would think that they are both pretty important. I'm not exactly sure how to answer that question. Do you want to take a crack at that one?
Well, yeah, anybody who's looking at the curvature of the universe, the expansion of the universe, is looking at space-time, not one or the other. It's a single unit. The study of time itself is, nobody knows what the heck it is. People are, there are people who will claim that time doesn't actually exist, it's just an illusion, which I don't quite see how it's possible, but I'm not a philosopher or a physicist. Time is time by itself, space by itself. We measure the size of it, we measure how far away things are, all that. With time, we honestly don't know what it is, and how it operates, and whether it's even real. So time is there's just this weird thing that is most happily discussed in the context of space-time, because when you get to time itself, nobody understands it.
Did you want to say anything else to that? No? Okay, good.
No, I'll
So
let
then
him.
here's a question in the back.
Hi, good evening, and thank you very much, first of all. My question is, Vera Rubin, when she was younger, what really motivated her to be a scientist, and not only just a scientist, but in the field of astronomy and physics related, because as far as I know, I study science, so not a lot of people, it feels like she was motivated to do it since a younger age, not really as she grew old, she was all of a sudden hey, I want to do it. So could you really expand on that, if that's possible?
Sure. I think a lot of it was her curiosity and just wanting to understand how the universe works. Just I mean, I don't know. I know kind of she had some experiences in high school with her physics teacher that, you know, he was not super supportive. And so I don't know that it was necessarily anything from a teacher perspective, but I will say her family was super supportive of her curiosity and trying to figure out kind of how just what the universe was and where we all fit in. I would say that sense of wonder is something that really drove her early on.
Could you speak to the physicality of being an astronomer? I know Margaret Burbidge talked very sentimentally about, you know, the times when back when an astronomer was up in a dome exposed to all the elements, often, you know, freezing temperatures, you know, dealing with, and then in the dark room with all those chemicals, and now it's pretty much looking at a computer screen, and you may not, I don't know if you even need to be at the site anymore. Did she ever speak to that aspect? And I guess that's a question.
Yeah, so she did talk about the idea of really enjoying being at the telescope and you know, climbing up into the dome and some of the experiences with the extreme temperatures, how she and Kent Ford would switch on and off, taking different observations while the other person was huddled next to a heater trying to stay warm and get ready to go up to take the next round of observations. And so there was that element of challenge to it. And then she did talk about the kind of shift to observing in a heated observing room, and things became very different, much more computerized. So when I spent some time at the telescope with her in the early 2000s, I got a sense that there was some nostalgia for the old days, but there were benefits of having some of the technology and being able to be warm and have things done on the computer. So I think there were sentiments both ways and really things that she loved about each way of doing those types of observations.
And it's true, you don't have to even, I was with an astronomer making observations at the Keck telescope in Hawaii, except he was in a basement in Berkeley. And there's no need for him to be there.
Here's another question from the queue from our online audience.
Okay, this one is, did Rubin express any preference for theoretical candidates for dark matter particles, such as, like, the reference here, winks and axions, anything like that? She had a top contender. What would it be?
I don't know that she necessarily did. I think, at least when I talked to her, she did try to kind of keep an open mind of what dark matter could be, just because I think, again, she didn't want to make any certain assumption about what it was. There could be that maybe she did have a leading candidate, but I don't think that she shared it with me from what I know.
We actually published an essay in Scientific American shortly after she died by a journalist who had covered her for many years. And he claims that she said to him, the headline was, Vera Rubin did not claim to have discovered dark matter. And the point being that, yes, she discovered what seemed likely to be a form of invisible matter, but she went open to the idea that it was something entirely different. And she did not, I think, have a candidate. She didn't even insist that dark matter existed. She insisted that she had made observations that were accurate, which everybody agreed, that pointed toward that strong possibility. But I don't think she went further than that.
That's such a nice image of a true scientist,
Yeah.
of acknowledging that the unknown always far exceeds what we know. That's really wonderful. I wonder if I could wrap us up with a question to both of you about craft. You are both writers who write for a non-expert audience, but you're experts and you have to be experts. And I just wonder about how you find a voice that allows you to, not to get lost in how, because the remarkable contributions are, I'm sure, often highly complex. And so how do you get to the audience in your mind that then helps you know where to simplify and where not to simplify? These are questions I think about for both of your work.
That's a really great question. I think that's the internal struggle maybe that all science writers have, is how much detail to go into. How do you make something accessible? Who is your audience? And so oftentimes when I was writing this book, I thought either about my grandmother or, some really curious student, maybe in middle school or high school, who was fascinated by the idea that we don't understand the universe, essentially. And how would I tell this story to that person if I were talking to them in conversation? What elements of the story would I draw out? What details might I try to leave on the cutting room floor, because you don't want to get too far into the weeds and then lose your audience. So it's this kind of balancing act and really trying to make sure that you are telling the story as accurately as possible, that there is a narrative arc to keep the story moving, but that you're not getting so lost in every detail that the story stops and readers stop reading.
Yeah, and I would say the same thing. I mean, if you have characters like Vera Rubin that you can introduce the readers to and get them to care about, then they're going to be more tolerant of, okay, well, I like this woman, she's interesting, and I'd like to know more about what interests her, and that gives you a leg up. And the other thing is just what Ashley said. We talk to people who don't follow this stuff all the time. Most people don't follow this stuff. And we talk to people and we have experiences where, or I think we both have experiences where you start to explain something and somebody's like, their eyes glaze over a little bit. Okay, now I know I went into too much detail. And you develop a sense of what the typical, intelligent, interested, but person who doesn't have a lot of knowledge is likely to be able to absorb. And you're not always right, but you get an instinct for it, I think.
Well, Ashley, you pulled this off beautifully, and it's particularly nice that you're sitting here with one of your teachers, it seems. That's a special combination. I invite you to thank our guests, but I want to also quickly say that if you want to pick up a copy of Ashley's book, she's going to sign in the back by that counter, and then Jacob can bring you out, and I will let you out upstairs. So I'm going to need a minute to get upstairs also. But join me in thanking both our guests.